Good morning. It's a good Wednesday, and I suppose it's a good time for an audio check too. Good morning. All right, everything is sounding good. It is 6:30, which means the heater should be turned off any second now and not having that lovely background noise. And in the meantime, I can just get my tea set up. And we can transition over. And oh, I need to get my chat set up too, just in case. Open up you and you. All right, so got chat all set up there. I think we're ready to go. So today we're going to keep things inside of a pen. What I mean by that, if we run the code that we have, it is working. We left it in sort of a working state. But as we can see, the dancing bots can just sort of dance off the screen. And what we want to implement is a stay in arena, which means that they can't go outside of the bounds. And so we have in bot RS here, down at the bottom, we have a test, keep in arena, and this is this function doesn't exist right now, so it will fail if we run that, and of course we need that in order to actually keep the bots in the arena. Good morning, iWumbo. So let's go ahead and implement that. Now the idea is that I want the full bot in the arena, not like half the bot, so we're gonna have to play around with the radius and figure out if we need to add pixels or anything else. Right now I'm just sort of assuming it's the bot.radius that needs to be shifted over, but we'll find out when we try it. So keep in arena off of the bot, so we can implement that here. So function keep in arena, this is going to take a mutable reference to self. And I don't think it needs anything else because the bot is actually tracking the arena width and arena height. So it knows exactly how big the arena is and where to go. So if we're in here, we need to check to see if we, well, basically, I think we need to just check, is our location.x greater than like arena, and then just set those specifically. So if self.location.x, so let's actually do top first. So if self.location.y plus the self.radius, and we'll parentheses this to make that go first. Good morning, stacking. It's also a very cold day. When I woke up, it was 16 degrees outside, which is where I'm happy that I live in a place that has central heating. Okay, so self.location.y plus self.radius. So that's like gonna shift it down a little bit, down to here. So if we add those, do we want to be less than 0? No, actually I think it would be minus. All right, if right here we want to stop. So if I take the radius, the location is right here, minus the radius, we'll put it right here. I think I want minus. So if location at y minus the self.radius is less than 0, maybe, yeah, less than 0, then I want to just like shift it down, just have it jump there. So self.location.y, we want to set this to, well, 0 plus, so like the top plus the self.radius. So we just do self.radius. Who cares about temperature when you have no reason to leave the house? That is nice to have that. I have plenty of reasons to leave the house today, unfortunately. So I don't have that fun. It's a problem, I think. But I get to go take the bus to work, and then later on today go smooze with some people and do some networking at local events. We can still see them like find the arena again and dance around. Okay, so if we have that, this will be at the top. Now we need to check if it's the bottom, and it can't be both. So this could be an else if. And this will be this exact same thing except the opposite. So self.location.y plus self.radius. If this is greater than self.arena height, then I'm going to multi-line this. Then we want to set self.location.y equals to, and I guess here's where it gets a little bit interesting, self.arena height minus self.radius. They're making me work on it. Well, the National Remembrance Day sort of came in very suddenly for us. And of course I'm not a federal employee. I'm just a private company. So yes, I think. Although it's more of like hackathon type work at work, so it's more of a fun day at work. Plus they're buying us lunch. You can't see any bots. That's because they're all invisible. And by invisible, I mean they literally walked off the scene and are like dancing way out here. Every once in a while, you'll see like a white circle come back on. That's the bot. We're trying to corral them right now to bring them back into line. All right, so we have this, and then we want exactly the same thing repeated again for the x. So I'm going to copy you. And so this will be instead of y, we'll change this with x, self.radius, and then wherever we do height, we want to change this to arena width. So I think this will work. Let's go ahead and give it a try. So first we'll run the test because we haven't actually implemented this yet. Cargo test. It's early enough in the morning I need to remember the commands, even though I was running them last night. Let's see. What did I do wrong? Oh, expected an F32, so these need to be 0.0. I keep on forgetting this also the first time I start coding in Rust again, each day. All right, let's try this again. Oh, you're in a private sector and they're giving you off. All right, so all the tests passed. So it did properly mutate. Now let's actually run keep in arena in the update. So after we move the bot, then we're going to self.keep in arena. And that's pretty much going to be it. We're just going to run that and then try this. So cargo run. And it does look like they're being kept in. No parts of them are getting out. So now we can watch the bots dance all day. So this is probably a good time to add a, okay, so keeping bots in the arena. Now we are slowly working towards outsourcing these bots into a Docker container. So I think maybe the next step is going to be to start moving towards that, and putting them into a thread. So we'll need to remember how to implement threads here. So when we instantiate a bot, we're really just opening up like a thread and then putting all the data about choosing what the bot's going to do inside there. Yep, I'm outsourcing them outside of this app as quickly as I can. No, I'm outsourcing to all of you guys. You all think you're just going to be playing a game, but you're all going to be creating cryptocurrency miners for me or something. That's the new thing to do, right? That's what you have other people do for you. All right, so with that in mind, let's think about where we want to do that. So we have our bot. We know that we're going, like, these bots are going to be instantiated, and there's 5 of these bots total right now. So that means each bot will open and track its own thread. There'll be 5 threads. When we create a new bot, we're going to want to store all of this, like the communication stuff for it. And we're going to want to make sure that we're probably going to want to have like the communication objects and methods available and stored inside the structure. So that way we can just communicate with them. In the draw, we need to grab we'll store their current location, everything else. It's really going to be update, where we're going to say like, hey, what do you want to do? And it's going to give us back that information. So what I'm thinking of here is we're going to be mean and tell them where they start. I guess it's not mean. It's just like, you're starting a random location in a bot. Figure it out. Maybe later on we can let the bot decide where it wants to start. Let's see. So we create a new location. We create the radius, which is 25 pixels, which is very large looking for here. But I think that's because the resolution of the computer when I'm using the capture card sort of scrunches everything down. So like the width here is 900 pixels, just sort of give reference. So there's really, I guess when we do new, we need to instantiate the thread, but we don't necessarily run any code in it yet. Like we'll tell it where it is and maybe how big it is. Like we'll give it the information. In draw, we're just going to literally draw where it is. And an update, we need to ask the thread, hey, what do you want to do? It should remember its previous location, but we can also remind it by sending in, hey, here's your current location. Here's like all the stuff that we know about you. Now, tell me what you want to do. And Dan, when we met with him in that mentor meeting, he did suggest to me that instead of like moving around, we just have the bot just stand still, just be there. So maybe that's what we'll end up doing. So let's hop to that. All right, so we'll want to go to what is it? It's Rust-lang thread. Is there a? There's the Rust by example book. I think I want to use that, or you just use standard thread. Right, we're going to do thread spawn and then the closure. And of course, we don't want to do res.child because that sort of like ends. Like it waits until everything is done. Nolix Dead Beef, good morning. Okay, so you can use a builder thread to spawn. Oh, and we can give it a name. This might be really good. So we can give bots names, and that might be easier to track them. Interesting. Thread local storage is a method of storing data into a global variable that each thread in a program will have its own copy of. And they don't share this data. So this might be a good way to have the state. It might be. I don't know for certain. Okay, so, oh, the default stack size for spawn threads is 2 megabytes. And there are 2 ways to manually, okay, so we can set the stack size so that people can't Stack Overflow us. That actually might be really nice to implement also. Yeah, I've been doing Rust dev. I've been learning Rust on stream for a little while now, but now I'm actually making a project with it. So it is awesome to sort of see Rust grow and get bigger. All right, and then we can do result. Let's go to, what is it? Rust-lang by example. Oh, you heard the thread size was a real problem. So I haven't gotten to yesterday, as I didn't really get much chance to work on the day 3, 5th star yet. I'm still sort of like slowly going through it when I have time. That's GitHub's. Yeah, this book, the Rust by example book. Where is, okay, compatible and safe testing. Oh, interesting. Okay. Did I not? I didn't see, can I search? Thread. Oh, it's under standard miscellaneous. Okay. Oh, these are so small. Can I make this bigger? Yeah. Okay, so use standard threads. Oh, they're keeping the static variable end threads to keep track how many threads you want. Okay, so make a vector to hold the children, which are spawned. So children threads, loop through. We're going to push thread spawn and then pass in the closure, which in this case is this just prints out what the thread is. And then of course they wait for all the children to be done. So that's not really that helpful. Is there more? No, of course not. Wait, this is still using threads. Okay. Right, mutex and channels. We're going to use that. Sort of like communicate with them. So, okay, so for text. I like how the thread, the example went from, all right, let's create the most basic thread possible to a ton more of information. All right, so we're gonna have our thread spawn. We get the data segment chunked data and enumerate, so that's where we get the index. Oh, but then we're just pushing that in there. And this joins them back up again. I can't remember. We can go to the book too. So Rust lang thread. We need that way to communicate. When you overload an example with that many comments, you know it's a bad example. It can feel that way sometimes. It felt to me that they were trying to explain outside of the example code, but they were also explaining inside the example code. And so for me, it just becomes a wall of text and very hard to actually sort of see what it is that I'm trying to look at. I need to put Rust, right? Why am I looking at .NET? Oh, this is the blog. Okay, so interesting. The book isn't right away. Okay, fine. We'll just go find the what was it? Mutex? I think it's mutex. These mutex will block threads. So data is right. We need the arc. It's in standard sync. And then we have the MPSC for channels. So yeah, we get the transaction, the TX and the RX for each thread, I think. That data TX. Right, we have to clone these because we're going to move them inside of the thread. Let's mute data. Okay, so we're getting this out of data. There's some thread stuff in chapter 20. I think I went through that a while ago, but it was long enough and I haven't done too much thread stuff since then that I would need to go look at that. So I think we'll go take a look at that next if this doesn't give us what we need. Right, because we could lock the data and unwrap it and that gives us access to the data. Oh, this is having, I think this is having the thread mutate data, right? So I don't need a mutex. I think, is it just arc? Yeah, let's go take a look at that. So Rust lang book 2018. Das was 2019. Huh, it's still on GitHub, found 2018. GitHub. Okay, we'll just go to here, 2018 edition. We need to go to chapter 20. Oh, that's okay. So that's building a multi-threaded web server. Did they talk about threads earlier? Fearless concurrency, threads. This might be where I want. Message passing, that's what I want. Here we go. Right, because we're going to use standard sync MPSC. We're going to get TX and RX from the channel. Now each of these threads are going to be completely different from each other, as in we don't want them to be able to communicate with each other or anything else. So I'm thinking that we should implement different ones. I don't know if there's going to be any memory implications from that. But I'm thinking that each bot should have its own TX and RX. So thread spawn move. That value equals string from high. So then tx.send. So this is sending out. This is how we'll find out what we want the bot to do. And maybe we can start with that. It just says, this is my current location, and it doesn't care about anything else. So we could try this. So we're going to bring in standard thread and standard sync MPSC. And we're going to get the TXRS and thread spawn move. Okay, so in bot. In fact, I'm going to move this to the right. Close U. That way we can reference this at the same time. Okay, so we want to use standard thread and use standard sync MPSC. Yeah, 2018 is coming tomorrow. I guess I was getting confused. I thought it was today for some reason, but I guess it's tomorrow. The first part of the 2018 edition, right? Okay, so we've got these, and next thing is that we're going to need to get the RX and TX and put them into a channel. And I think we're going to need to... TX is the send there, and we can receive. We're going to need to move. So we need to clone it when it comes in. Boring part one with just RLS 1. Hey, I'm not going to be, I'm not upset with a new version of RLS. That might make VS Code a little bit better with it. All right, so in our bot, we want to create a new one here, which means that we need to hold the TX and the RX for us. This is going to get a little bit more interesting. So let TXRX, I need to hold this for a long time, so we need to store them in here, don't we? Because I don't think I can get this over and over again, right? Or can I run it again and get TX and RX again? Those are good questions that I don't actually know the answer to. So let's try not spawning them and just run MPSC channel again. It may get the same channel twice. Unless you know. If one of you knows, please let me know. Do I need to store TX and RX inside of the structure so that the difference between the initializing a bot and like each time I run update, can I just get this channel again? Okay, so I needed to store it in a struct. All right, so that kind of makes sense. So inside of here, we're gonna put, I'm guessing these are gonna be like thread channels, thread channels, and we're gonna have this be a tuple of, I don't know what type this is. That's here in function new, we'll do let txrx equals mpsc channel, like that. Will you tell me the type? It is a type sender. Okay, so you need standard sync MPSC sender. Okay, so channels, this will be MPSC sender, like that. MPSC sender. There's a crossbeam channel. Let's see, multi-producer, multi-consumer channels for message passing. Oh, so this is like a crate that will, it's an alternative to MPSC with more features and better performance. Oh, interesting. I was kind of hoping they would have documentation here too. I mean, I guess they have examples, but Fibonacci. Okay, so we bring in crossbeam channel, use thread, so bounded and sender. They have the, well, I know, I was just hoping for like actual, like a little snippet of code right here, as opposed to like, okay, let's go hit the docs, because the docs usually doesn't have the code examples, right? Oh, I guess it does here. Use crossbeam example, use crossbeam channel, unbounded, let sender and receiver equals unbounded, and run that. Send a message into the channel, s.send hello world.unwrap, receive the message from the channel, assert equal r.rec v hello world. So it's like similar API. Crossbeam channel bound. So create a bounded channel. Creates a channel of bounded capacity. There's a limit to how many messages it can hold at a time. Okay, so I'm probably going to just do ooh, that's a good question. I could do unbounded. I don't know, like I might have to play around with that. So, okay. You're gonna send 5 messages in, which just sends the I. Create an unbounded channel and just send as many as you want. Senders and receivers can be cloned and sent to other threads. Yeah, we could try this out. This looks pretty good. So let's, what is it? Crossbeam. Is 032 the one that's recommended? All right, let's go verify that's what they have here. Yeah. Copy from you. Cargo.toml file, and we'll add in crossbeam channel. And because it'll probably take a while, let's cargo, I don't know, we'll run the test. That will start compiling it. I did find that one stacking. I don't miss everything, just a lot of things. Okay, so we can come back to here and we can sort of like start setting this. Now, we still don't know what type this is, so also wrong number. Oh, it's expecting me to have like a specific type in here for this one, but we're going to be slightly different now. So we want to, instead of bringing, I guess we still need thread. We need to use crossbeam channel bounded. So this one will be different. Oh, and we need extern crate. Extern crate crossbeam channel. We'll use crossbeam channel, I guess, unbounded for now. And then we'll figure it out when we run into limitations. Okay, so what are you upset about? Unresolved, okay. Did you mean self crossbeam channel? Crate name using dashes are not valid crate names. Oh, so it has to be, hold on, let's go back to their example, their documentation. No, not the documentation, their GitHub. And what happened to their examples? I thought, oh, their GitHub is a different branch or slightly looking at it. Also, this was crossbeam. Okay, now I'm confused. I'm not looking at the same thing. So this is crossbeam channel. Right, okay. Extern crate crossbeam underscore channel, which is different than, okay, crossbeam underscore channel, but this was crossbeam dash channel. Okay, for maximum confusing, so it needs to be underscore. Something that's always bothered me is like why did they why do you do that? You could just enforce that across everything and just like not allow the dash in the cargo toml either. Okay, this library is an alternative to, okay, so we're going to do that. Use crossbeam channel unbounded. We have you, have you figured out? Do I need this to be self to sort of like figure out that it's its own thing and then bring that in here? I did not need to do that with rand, but did I bring in rand into lib? Oh, I did. So it's probably not even using the extern crate, is it? So in bot, I probably don't even need this rand, do I? This can be a self. Okay, now it's telling me we haven't used it yet. That's fine. Then grid channel of unbounded capacity. Let's go find the actual thread we're creating. Here it is. We'll do the, I mean, unbounded and bounded are pretty much the same thing. We're just not saying what the capacity is. So, okay, use thread. We're going to get the receiver and a sender. So we can do that when we create a new bot. So I will worry about this in a second. So I'm gonna just call these what they are. So sender, receiver equals, and it's gonna be unbounded. And I think that's just it, because we don't need to pass anything in, I don't believe. Yeah, it's gonna return back the sender and receiver. Then we're gonna spawn the thread and move probably both of these in. So we'll need clones of that too in order to like receive out later. So we'll start with just moving a sender in, and we'll keep the receiver ourselves. So that'll be the next thing. Now when I thread spawn, I don't need to keep that anywhere. So it just spawns. So we can just do thread spawn. We're going to move into it. And at this point in time, we want to tell it the location of where we want to go. So let's tell the bot to be right, maybe right in like 250, 250. That might be good. So we'll do sender. So sender dot send, and the message is I want, how do I want to do, like JSON would be good type stuff, but I don't know if I want to like get the entire Verde and like it's like internal to us. I know it's going to be like maybe a string and parse it out. Can I do I guess a tuple type thing? Where I could say like width is going to be this. So I could send out a string, like an actual string. So here, let's do this. Let sort of like location equals, it's going to be a new, so I can just give it a new point. So point new, and we want like 250.0, 250.0, and that's pretty much going to be it. And we're going to send the location. Dot unwrap, and be done with that. Okay, so you're not erroring out with me yet. Also, this was not being used anymore. Then we're going to receive this and set the location of where it's going to be. Okay, so we want to 250, 250. Down here in draw, we want to get the location, so we need to receive it. So we need to store this in the bot so we can get it down here. All right, so this will be the thread messaging, and this will be probably a tuple of whatever this is. It's sender point point. Okay, so this is a sender point. And I don't need to restore the receiver yet. So maybe I'll just call this thread sender and not have this be a tuple. And there, will just be a sender point. What really are you? You're a crossbeam channel sender point. So crossbeam channel, let's also wrap you and grab sender out. Okay, so we've got the sender. Now inside, well, bot's gonna be upset because we're not passing it in. We can just do that right now. So thread sender is going to be our sender. Okay, so you should be happy now once RLS updates. Your use of moved value, oh no, not sender. I need receiver. Hold on. This, I was wrong. I got it confused. Thread receiver. And this will be the receiver. We need to pull receiver out. It's going to be a point that we're getting, and thread receiver. Receiver. That's what we want. Mismatch types, expected bot struct. What? Oh, never mind. It updated and decided we don't have mismatch types. Okay, so in draw, we now have access to bot. We have access to the receiver. We're going to receiver.recv and get the location, the point of where we want to go. So in draw, we're going to say let, well, actually, you know what? It's going to be more interesting. We're going to, in update, ask the thread where the bot wants to be. So instead of this entire random location thing here, we're going to get rid of this. And we're going to say, okay, self.location is now going to be equal. So we're just going to set this equal to the point. So that will be self.recv.unwrap. I'm actually surprised there's no unwrap that's needed here. Oh, there is an unwrap because this was an okay on this side. Okay, so unwrap. And that gives, we're just updating the location at that point in time. We don't need to move the bot now. And we can still run keep in arena. But the idea is that the bot should just be still we could have 5 of them, but they're all going to be in one location. And later on, we can just pass in the random location, sort of have them move around a little bit. So let's see if this works. So cargo run. Well, that was fast. All right, so we panicked immediately on an unwrap error value. Oh, because we only set, well, unwrap on error value, recv error. I think it's because we need to be like constantly sending that message, don't we? Like every time we ask it, we want it to resend back. And is there, I guess with bounded, I could say you're only allowed to have one message in there. And then what happens if I try to send too many? Okay. Another call to send would block because the channel is full. S.send 5 unwrap. So this would basically wait until it's ready. Okay, so I think we want to do bounded. So let's change this to bounded when we create a new one, it's going to be bounded, and we're going to give it a cap of 1. And of course, this just runs once, so I really want to put this into an infinite loop where it's just constantly setting this location. And because that, we can have that variable outside of there, and then we'll constantly send out. Use of moved val. Well, okay. Yeah, I move it into this one here. Oh, it moved in here. I didn't want that. Okay, so hold on. I guess like point. Just call this. I'll just call this L for right now, for lack of a better name. Are you gonna use move value L? Right, I'm moving it into here. Wait, do I not want to move it? If I put you in here, you're fine though, right? Except if I... Interesting. So just moving into the... Oh, right, because each time the loop ends, it starts over again. It gets sort of like reset. So this might be best for right now, especially since later on I'm going to like be resetting and creating new points and telling them where to go. That will not be the same. So this will probably be best. All right, so we're going to start with this and center net send. This should block it, so it can't go on to the next one until the previous message has been read, which will be at that point. So let's try this again. Oh, and here it is at this. So there's 5 bots here in 5 different threads, and all just hanging out in this location. So now I can, we can set the entire random location and just have them dance inside of here. So that might be the next thing we can do in like 10 minutes or less. So we already have random set up. Where arena height, we were doing, this was random, getting like a random number. I think we can, locations, these are, do I want to tell it where it is randomly? Maybe. These bots must be eating your CPU like crazy. Oh, am I dropping? So it shouldn't be that, because my streaming computer is on a completely different computer. So I'm dropping frames on like over here. And yeah, this is dropping a significant number of frames right now. I wonder, is like there's suddenly anything going on? Remember last time this happened, it was like the Olympics or some major event was happening that was like everybody was tuning in to watch at the exact same time for a week. We're back to green again. So that's not good. We lost 1.6% of the entire stream's frames within the last minute. That's not a good sign. All right. What I wanted to do, the idea is that we're going to tell the bot we're going to tell the code, okay, here's like where you're at. Here's where we know that you're at. And then you're going to like send back where you want to be. So I'm thinking we send it a point of it. We're probably gonna have to implement copy for our point trait so we can copy it in for right now. And now this would be an update. So we have to tell we have to send into the thread, here is where you're at. And we're gonna get back where it wants to be, like the next location where it's going to be. So what I'm thinking is we need to also send thread sender in here. So thread sender is going to be a, which means we need bounded receiver and sender. This is now going to be a sender of type, we'll just do point for right now. When we create a new bot, we have sender and receiver. We can clone these should be fine. So we actually want to, we have to clone it ahead of time, I believe. So here is let t, I guess like thread sender equals sender dot clone, and let thread receiver equals receiver dot clone. So we'll just do this because we're gonna need both in here, and this way we have thread receiver is just like that now, and thread sender is also stored in here. Am I still, no, about the same number of drop frames. Okay, so we're now keeping these available for us later. When we first start and create the thread, we need to tell it where it is. So we're probably gonna have to, not necessarily a struct bot, but we're gonna have to tell it like its current location. So it'll be something like let location equal, except like I can't really do this, so that let bot location equals, and I guess we could let them decide where to go. So we can start here and we'll let them all I accidentally hit Command C twice. Okay, so X here, there. So we have our random number generator, we get a random X and Y. Bot location is going to become a point new with X and Y. And then that gives us our bot location, and we send, we just send this location. We can update it later. So we're gonna send the bot. So the bot location, except it's not really gonna be, I guess for right now, let's just have it constantly moving to the right. And we have add assign. Actually, I'm kind of surprised this is working. This should tell us that we're moving it. Because like the second time through the loop, it's going to say, hey, you've already moved bot location. You can't do this. So I think bot location, we want to create a new location. We want to reassign. So we want this to be mutable. we want the current, we want like the next location that we're just going to be. Okay, so that's going to be like we're gonna have to set like a velocity and everything else. I don't think we need to be that crazy with it, but we could just add a sign like 1 1 1 and have it just move diagonal down. So we'll create a velocity. So let velocity equals point new 1.0 1.0. So hopefully this should be a very slow moving bot. We're running up on our time, so that we'll only have one chance to implement this. And then we'll need to now add a sign into bot location inside the loop. So bot location plus equals velocity. Okay, so we'll do that. I need to clone the bot location. So we'll just create like new location right now. So we'll just do point until we'll need to implement the clone trait so that we can actually do that on our special on this point. But until then, we'll just get around to it with bot location.x and bot. Oh, that was not happy. Bot location dot y, and we'll pass in point, and that should work. We have one up here. Location point new. Okay, so that's why you weren't giving me any errors, because we had that one. We do need a location of some kind to set it off, because like we're not able to pass this in here. This is setting bot location is a random. Are we just doing anything here? We're just setting location in right here. So I think we could basically, here, let's just do this. Let location equals point new 0.0 0.0. It's kind of like a BS pointer. We should really use like options and everything else, but okay, so then velocity. Okay, now we're basically running to the problem where we need to put this in here. Only because of the moving rules, we need to implement clone so we can actually do that properly. All right, let's try this. The idea is that we're going to see it move in a very slow downwards and to the right. Hey, and it does work. And our keeping them in arena also worked because they all just hit the edge of the screen. So if we run that again really quickly. They all start in random locations. We have 5 threads and 5 bots in those threads. They just move downwards and to the right until they hit the walls, and they all accumulate down here, where they are attempting to move away, but they can't. And what's interesting here is that the bots are all updating their location, and so they're way off to the side, down that way, yeah. And they can't actually get there, even though they think they are. So that'll have to be something we work on later. But I've got to go get ready for the rest of my day, so I'm going to switch over to my ending scene. I need to update the dates that I'm that I'm streaming, because I have been streaming a little bit half an hour earlier recently. I've been streaming at 6:30 a.m. Mountain Time instead of 7. Oh, Shadowcore, you've tried Rust before? Yeah, the borrow system can be a little bit tough to get used to, but I found that I'm still wrapping my head around it a little bit, but it's helping me with other code. I guess like just sort of thinking about ownership and only being able to have one piece of code own something at the same time. And from what I understand, this makes thread usage a little bit easier because, as you can notice, I can't accidentally hand something to a thread and not to another one. It makes it a little bit interesting. But we'll be moving on to that next time. I've got to go get ready for the rest of my day and go catch a bus. I hope all of you have a great rest of your days, regardless of whether or not your day is coming to an end or in the middle. I will enjoy my National Remembrance Day by working and maybe doing some Advent of Code during the day. I'm not sure. And with that, have a great one, and I'll see you next time.